Hello everyone and welcome to the lecture on AWS Tools and SDKs. So this lecture will contain all these topics: tools, SDKs, shared config and credentials files, profiles, credentials files, environment variables for access, test profiles in config file, AWS service specific settings, AWS SSO for IAM Identity Center, Python sample program using Boto3, authentication options for code running locally, that is not in AWS, authentication options for code running within an AWS environment, and the precedence level. So the tools which are part of AWS Tools and SDKs are AWS Cloud9, AWS CDK Cloud Development Kit, AWS Toolkit for Azure DevOps, AWS Toolkit for JetBrains, AWS Toolkit for Visual Studio, and AWS Toolkit for Visual Studio Code. So these toolkits are basically plugin or extensions which you can install and work with AWS easily. And then we have AWS serverless application model. Then we have AWS Code Artifact, AWS Code Build, Amazon Code Catalyst, AWS Code Commit, AWS Code Deploy, and AWS Code Pipeline. And the SDK, which is our like software development kits. So we have these are the options. So we have AWS CLI, which we have seen. So you can directly interact using the AWS CLI command line interface. And then we have SDKs to basically automate all tasks related to AWS. So we have AWS SDK for C++, for Go, for Java, for JavaScript, for Kotlin, and for .NET, and for PHP. And Python, we have Boto3 library, and SDK for Ruby, and for Rust, Swift, and AWS tools for Windows PowerShell. So basically in Windows PowerShell, you can install and you can directly work. So this is very similar to AWS CLI. So shared config and credentials file. So when you work with AWS CLI or SDKs, so there's two main file. One is config file. The name is exactly config, and there's a credentials file. And we have something called as profiles. So profiles in the shared AWS config and credentials files are a set of configuration settings in key value pairs. These profiles are used by the AWS command line interface, AWS SDKs, and all the tools. Configuration values are attached to a profile to configure some aspect of the SDK or tool when that profile is used. These files are shared because the values affect any applications, processes, or SDKs on the local environment for a user. Both the shared config and credentials files are plain text files containing only ASCII characters UTF-8 encoded and take the form of INI file format. Then we have profiles. So the profiles, they are the organizational structure used within the shared config and credential files. Settings within these files are associated with specific profiles, which allows multiple configurations to be defined for different development environments. So you can create as many profiles as you want, and in your application you can refer to a profile, and that will affect what settings or what kind of permissions that application can use. Then we have something called as default profile, and we use the default keyword. And this contains value used by an SDK or the tool when no specific name profile is specified. And this serves as the fallback configuration when you don't provide any explicit profile. So if you don't provide, automatically this will be taken into account. Then we have named profiles. So you can create additional profiles that can be explicitly referenced by name. And this allows different settings and values to be used as needed by your application and the scenario. Based on the scenario, these provide the flexibility to maintain separate configurations for different development environments. So this is an example of credentials file. So by default, if you have installed AWS CLI, this is the first step that you will do. So we have AWS access key ID. This identifies the IAM user or the role. So this is just think of like a username, but we never use username directly. When you log into AWS console, you use username. But CLI, this is the unique username you can think of. Then we have secret access key, and you can think of this as a password. And this is associated, they are both linked together. Key ID and access key are like a pair. Then we have environment variables for access. So in your application, you can just set up, so you can use the profile or the credentials, but you can directly, this is temporary setup. So you can do export access key ID, secret access key, or the session token. So this is same if you are not specifying, but some of the, for example, CI CD tool or something, or for just local testing, you can set up or override these, and you can test. Let's say you are checking permissions and all, and then you can have a region also. So if you don't specify anything, the US East one will be taken. But depending on the region, you must remember to set up. Otherwise, let's say you are listing EC2 and you have not set up the region, the results may say you don't have any EC2 or whatever. So make sure you remember to set up the AWS region. And these are the default names. That names must be exactly same, and you provide those values. Then we have test profile. So default profile you have, but if you want to create a name profile, you can say profile equal to test. And this is the example of config file. And you can specify a region, and then based on that you have some AWS specific settings also. For example, we have S3 here, and this begins the S3 specific configuration block for optimizing S3 operations. So you will have a 4 space indent, and you can set the maximum number of concurrent API requests that can be made to S3. And next is max queue size. This specifies the maximum number of operations that can be queued before blocking additional operations. Then we have AWS service specific settings. So I gave the example of S3 before, and for example here we have another profile dev, and we have services like local DynamoDB. This specifies that this profile uses a local service configuration named local DynamoDB, and the service, for example, this must match begins the DynamoDB specific configuration block for the local service. And here we have set up an endpoint for the local DynamoDB, and this sets the endpoint URL to point to a locally running DynamoDB instance on port 8000. Now then we have AWS SSO. So this will be used maximum in any kind of enterprise where they have set up single sign-on, and this is slightly different. So if you have set up AWS CLI, you will see the config and credentials file. But if you have AWS SSO set up in your organization, this is how it will look like. So first we have the SSO session. So this specify the name of SSO session to use for this profile. So we have dev profile, and you can have dev, test, QA, prod. So you can have 4 different set of settings. So they'll be like repeated 3 times, 4 times, whatever, based on the number of session. So this is saying my SSO, and this is pointing to here. Then number 2 is AWS account ID, where the SSO enabled role exists. So this is where the SSO role exists. So this is the AWS account ID. This is a 12-digit number. Then name of the IAM role to assume via SSO. Once you have logged in, this is the role that you will get. Then AWS region, where the SSO service is configured. So this is so you can specify, and this is important, start URL. So the URL of your organization's SSO portal where the authentication begins. So every organization will have some start URL. This is the default, and this is where you will be authenticated first time. So when you do AWS CLI, it will launch. It will open a browser tab, your browser window, and you will enter your details. Once it's authenticated, you can close that browser, and the session will be established in the CLI or in the application. Then I will just show you a Python sample program using Boto3. So this comes part of SDK. So this is the Boto3 library. So for example, here I am just creating a method. So this is the SDK demo, and I am initializing. First is to create an S3 client using Boto3. And this client provides access to all S3 operations. So this is how we do. And this is another. And this is for EC2 operations. And then let's say I'm just listing S3 buckets. So I'm saying S3 list buckets. And this will list all the S3 buckets. And then this will be a like a JSON response. And then this response I have to pass, and I'm printing out the bucket name and when was it's created. So this is how I get the bucket object from the response, which will be like array of buckets, and I can traverse like name, creation bucket, and I'm just printing it out. Now let's say how to list the EC2 instances. So again, EC2 describe instances, then I get a response, and then based on that, I'm checking out the reservation. So here, I navigate through all the nested response structure. Then EC2 responses are organized by reservations containing instances. And then I'm just printing out the instance ID, the state, the type, and the launch time. When was the EC2 instance was launched? And here, this demonstrates the this demonstrates defensive programming by checking if the tag key exists before attempting to access. So I'm just saying if tags exist or not. If yes, then I'm printing out the tags. And this is because there are two methods. No, there is only one method and there are two things. But here I am just saying, if this program is directly called through the main, then I'm saying run this AWS SDK demo. So this is the like public static void main or the entry point for this Python program. And if any error, I'm capturing it and displaying it. So authentication options for code running locally, that is on your machine or laptop or not in AWS environment or any server. So these are the options. So we have IAM, Identity Center Authentication, and this uses AWS organizations. So this we have to use organization service with IAM Identity Center to manage access across all your AWS accounts. You can create users in IAM Identity Center using Microsoft AD. You can use a SAML 2.0 identity provider or individually federate your IDP to your AWS accounts. Then we have IAM roles anywhere. So this is another service or another component or another technology I can say. And this can be used to obtain temporary security credentials in IAM for workloads such as servers, containers and applications that run outside of your AWS. And your workloads must use X509 certificate. So this is a certificate based. So you have to install or mutually create trust, and then these certificates will be passed around, and then you get an access, and this will be a temporary access. Next, you can assume a role with AWS credentials. So you can assume an IAM role to temporarily access AWS resources that you might not have access to otherwise. But this you have to set up permissions and all. And then you have AWS access key and other options that might be less convenient or might increase the security risk, which is a default like you configure in your CLI interface or in the credentials file. Then authentication options for if you are within AWS environment. So these are options. We have EC2 credential automation. So when your application is hosted on Amazon EC2 and that has an associated IAM role, the credentials are automatically made available to your application. This provides seamless authentication for applications running on EC2. So basically you attach an IAM role profile to the EC2 and that gets access to all the underlying services. Then we have container credential automation, and this is for applications running in Amazon ECS container services or the Elastic Kubernetes services containers. The credentials set for the IAM role can be automatically obtained through the SDK's credential provider chain. So this is part of the container setup. When you work with EKS, you will be knowing like how to set up this. Then IAM roles for EC2. So you use IAM roles to securely run your application on EC2 instance. And then we have IAM Identity Center interaction. And here you can also programmatically interact with AWS using IAM Identity Center by using AWS Cloud Shell or to run your AWS CLI commands from the console. So this is very straightforward. You just click and you log into Cloud Shell and you have complete or total access to all your AWS services, provided that you have somebody has given you access or you are the admin. Then this is last, like what is the precedence level of how the credentials or the config are loaded. So first is you have explicitly mentioned those settings in the code. So this is the first preference. Any explicit settings set in the code or on service client itself takes the highest precedence over anything else. Next is you have per operation settings. So settings set on a per operation basis, and this can be changed as needed for each operation. So you, let's say, create user, modify user, delete user. So you can have per operation setting also. And for CLI or PowerShell, these parameters entered on the command line. So for every operation also you can give per operation. Then we have JVM system property, and this is for Java and Kotlin only. The JVM setting property for the setting is checked. If it is set, that value is used to configure the client. Then we have environment variables. The environment variable is checked. If it is set, that value is used to configure the client. Number 5 is shared credentials file. The SDK checks the shared credentials file for the setting, and if it is set, the client uses that. Then we have shared config file. The shared config file for the setting, if the setting is present, then the SDK will use that. And lastly, we have the profile specification. And here the AWS profile environment variable or the AWS.profile in case of a JVM system property, that will be used to specify which profile that the SDK software development kit loads. And we have SDK default values. Any default value provided by the SDK source code itself is used last. And that's all. Thanks for watching.